Okay, so we're trying to work out the equation for a line. This is going to be important for the next stage of what we're going to be doing to work out the equation for a tangent of a circle. We know how to do perpendicular gradients. We know how to do equations for a circle. We need to know how to do work out the equation for a line when we have a couple of coordinates. Now, a lot of the time, you might this kind of question you're going to have to do outside of knowing anything to do with circular graphs and so on. This is a different skill. It's just a tool which you can use to do that. And you also may not have the actual graph that we've got here. But anyway, so we're going to do it in two different methods and show you how they both give us the same answer. So point 1, the coordinate is -4 and 4, and point 2, the coordinates are 4 and -2. Now, I can see from the diagram it's going to have a negative gradient, and we could cheat really, and find roughly what the intercept is. It looks like it's going to be about 1, maybe exactly 1. But as I said, you may have to do this without the graph drawn for you, and so you wouldn't necessarily know that it's a negative gradient or what the y-intercept would be. We're going to first of all look at it like we can see it, and so we're going to treat it like it is a regular graph and that we can see the points, and we're going to calculate the gradient. So we look at the change in the x, and we can see that it is clearly 8. But just to be clear, what we do really is we're doing the second x coordinate minus the first x coordinate, which is 4 minus -4, which as you can see is 8. Then the y coordinate, the change in the y is the second y value minus the first y value, which is -2 minus 4. Now, it's important that we do it the right way around. If I do x2 minus x1, I've got to do y2 minus y1, and that will make sure that I get the right sign. Otherwise, I get a negative or a positive gradient. I want to make sure I get the right one. Otherwise, I won't get an accurate answer. So -2 minus 4 is going to give me -6. Right? Yeah, that's right. So hang on a sec. Yeah, that's right. Yeah, that's right. So to work out the gradient of a line is the change in y over the change in x. So that's going to be -6 over 8. So you can simplify that, and you can say it's -3/4, or if you want -0.75. Now we know that the equation for the line is going to be y is equal to mx plus c, and now we know what m is. We can look at either one of these two coordinates, and we can say, well, at point 1, y is equal to 4 and x is equal to -4. So actually we could say that 4 is equal to -4m plus c. And we know what m is. It's -3/4. So I'll write in this bit here. So 4 is equal to -4 times -3/4 plus c. We've got a minus times a minus there, so they're going to cancel out. And you got the 4 times the 3/4, so you got the 4 there is going to cancel out with that 4. So you end up with 4 is equal to 3 plus c. And then you would subtract 3 from both sides, and you got c is equal to, and I've flipped it around as well, c is equal to 1, which is what it looks like on the diagram. Now we've got the equation for the line, which is, where shall I write this? I'll write this, actually I'll just type it right in. So y is equal to, m is -3/4, so I'm going to do -3/4 and then x plus c. Oh, negative. Oh, right. Sorry. Yeah, that's what's gone wrong there. I shouldn't be writing c. I'll be writing what the c is, which is 1. And it does, in fact, go through those points. Now, what about then if we didn't have the graph? What if it was hard to actually visualize how to calculate the gradient? Well, we could still just do that the gradient is the change in y with the change in x, so that the gradient is equal to y2 minus y1 divided by x2 minus x1, and you wouldn't need any picture then. You just sub in the values that you've got. But you could also treat it like a simultaneous equation. So we've got our first equation up here, equation 1, 4 is equal to negative 4m plus c, and the second equation is y is negative 2, so negative 2 is equal to 4m plus c. Now, what you can do if you're familiar with simultaneous equations in this way, I would always subtract one equation from the other. Doesn't matter a great deal about which one you subtract from what, but I'm going to do it that way around this time. And the reason why is because the c's are going to cancel out. So on the left-hand side, I've got 4 take away negative 2, and that's going to be 6. And then on the right-hand side, I've got negative 4m take away 4m. That's going to give me negative 8m. And then got c take away c, which is just nothing. So I divide both sides by negative 8, and I've got m is equal to 6 over negative 8, which is negative 3/4. So it's the same as what we've got up here. The second stage to work out c is what we did anyway. You would just sub it into either of the two equations. It doesn't matter which one you choose. You can use equation 1 or equation 2, and you'll get the answer. So that is how you work out the equation of a line if you only have some coordinates. And it works. You should be able to know how to do that if you've got the graph or you've just got the coordinates written down. Okay.